Most of us do not think much about storm drains. They sit quietly at the edge of the road, tucked beside curbs, hidden in grates or built into gutters. Most of the time they are almost invisible, just another part of the street we walk or drive past without noticing. But when heavy rain hits a city, those quiet metal grates suddenly become part of something much bigger. Water rushes across roads, down pavements, through gutters and into an underground system that most people never see. And that system is doing something incredibly important. It is trying to stop the city from flooding. Beneath streets, car parks, neighbourhoods, parks and intersections, cities rely on hidden networks of storm drains, pipes, culverts, channels and basins to move rainwater away before it causes damage. Because when that system works, hardly anyone notices. When it fails, everyone notices. Roads flood, cars stall, homes fill with water, intersections turn into ponds, and suddenly a piece of infrastructure most people have never thought about becomes very hard to ignore. So in this video, we are going underground to explore one of the most overlooked systems in urban life, the hidden storm drain systems beneath cities. We will look at what storm drains actually are, how they work, where the water goes, why cities need them, how pollution travels through them, and what happens when these systems get blocked, overwhelmed, or simply outmatched by the weather. Because beneath every modern city is a hidden network designed for one simple purpose: to make rain disappear. Which, when you think about it, is quite an ambitious job description. Let's start with the basics. A storm drain system is designed to collect and move rainwater away from streets, buildings, and developed land. That includes water falling on roads, roofs, pavements, car parks, and other hard surfaces. In natural landscapes, much of that rain would soak into soil, spread into vegetation, or slowly move into streams and groundwater. But cities replace a lot of that natural surface with concrete, asphalt, rooftops, and other materials that do not absorb much water. That means rain runs off much faster, and unless you provide a route for that water to go somewhere, it starts to pool in the places people really do not want it. Roads, underpasses, basements, garages, and low-lying neighbourhoods. So, cities build systems to capture that runoff and move it away. At the surface, that usually begins with a storm drain inlet. That might be a grate in the street, a curb opening along the edge of the road, or a drain built into a paved area. When rainwater flows along the gutter line, the drain collects it and sends it into underground pipes. From there, the water enters a network, and that network can be surprisingly extensive. Small local pipes collect runoff from streets and neighbourhoods. Those pipes connect to larger storm sewers, culverts, channels, or drainage tunnels. Eventually, the water may be directed into detention basins, retention ponds, open drainage channels, rivers, lakes, or the coast, depending on how the city is built. This is one of the first important things to understand. In many cities, storm drains are not the same as the sanitary sewer system. The sanitary sewer carries wastewater from toilets, sinks, showers, and buildings to treatment plants. Storm drains, by contrast, usually carry rainwater runoff. That means the water entering a storm drain often does not go to a treatment plant first. In many cases, it goes more directly into natural waterways after moving through the drainage system. That is why you sometimes see messages near drains telling people that they lead to rivers or oceans. They are not being poetic, they are being alarmingly literal. And this is where the story gets more interesting, because storm drain systems do much more than just move rainwater off roads. They shape how cities survive storms. Imagine a heavy downpour hitting a dense urban area. Rain lands on buildings, roads, pavements, parking lots, sports courts, loading areas, rooftops, and alleys. Almost immediately, water begins running across those surfaces, following gravity downhill. It flows into gutters, downsloped streets, and toward low points. Without drainage, water would accumulate quickly. That creates hydroplaning risks for drivers, flooding hazards for pedestrians, damage to property, erosion around roads and foundations, and serious strain on transport systems. So the storm drain network is designed to intercept that movement. The surface inlets are the visible entry points. But once water disappears below the grate, it enters a hidden engineered landscape. Some of that landscape is made of circular concrete pipes. Some of it is boxed culverts beneath roads. Some of it is open flood channels lined with concrete or vegetation. Some of it is underground tunnels large enough for maintenance crews to walk through. And in some cities, especially older or more flood-prone ones, the stormwater system can include massive underground storage structures designed to temporarily hold excess water during intense storms. This is one of the reasons storm drainage is such an interesting kind of infrastructure. It is not just about movement, it is also about timing. A city does not always want stormwater to rush out all at once. In many cases, that would overwhelm downstream channels and waterways. So part of the system is built to slow water down, store it temporarily, and release it more gradually. That is where detention basins and retention ponds come in. A detention basin is designed to temporarily hold stormwater during or after a storm and then release it slowly. A retention pond holds water more permanently and may provide storage capacity above its normal level during storms. These systems help reduce peak flooding, control erosion, and prevent sudden surges downstream. They may look like empty basins, landscape depressions, or ordinary ponds in parks and developments, but many of them are working pieces of flood control infrastructure. In other words, some city ponds are not just decorative, they are employed, and they are doing more than some people in office meetings. But even with all this infrastructure, stormwater is not just a hydraulic problem. It is also a pollution problem, because rainwater moving across a city does not stay clean for long. As runoff flows over roads and paved surfaces, it can pick up oil, tire particles, brake dust, fertilizers, pesticides, litter, sediment, pet waste, heavy metals, and all sorts of debris. That material gets washed into storm drains along with the water. So the storm drain system often becomes a transport network, not just for rain, but for pollution. If the water is not treated before reaching streams, rivers, lakes, or coastal waters, those pollutants can enter the environment directly. This is why people are warned not to dump paint, chemicals, or rubbish into storm drains. To some people, a drain might look like a convenient hole in the ground. To the watershed, it is an express delivery service. That also means blockages matter. Leaves, branches, litter, plastic bags, sediment, and illegally dumped material can clog inlets and pipes. When that happens, the system loses capacity right at the moment it is needed most. A blocked inlet during a heavy storm can cause rapid local flooding, even if the rest of the network is functioning normally. And because stormwater systems are spread across entire cities, maintenance is constant. Public works teams inspect drains, clear debris, vacuum sediment from catch basins, repair damaged pipes, inspect tunnels with cameras, and remove obstructions before storm seasons. In some places, crews also monitor flood-prone locations in real time during large storm events. This maintenance is easy to overlook because it is so routine. But like many kinds of infrastructure, the routine part is what keeps the dramatic part from happening, because when maintenance slips, the consequences can be fast. Water ponds where it should not. Roads become impassable. Basements flood, streams overtop, traffic backs up, emergency crews get stretched thin, and the public suddenly discovers that storm drains were, in fact, doing something important all along. There is another challenge too: scale. Many storm drain systems were designed for weather patterns, land use, and city layouts from decades ago. But cities change. Neighbourhoods become denser, open land becomes pavement, old drainage paths are disrupted, and in many places, storms are becoming more intense. That means some drainage systems are being asked to handle more water faster in places that are less absorbent than when the systems were first built. This is why cities increasingly add new layers of stormwater management. Permeable pavements allow some water to soak through. Green roofs reduce runoff from buildings. Rain gardens and bioswales help capture and filter water at the surface. Expanded detention systems provide temporary storage, and updated flood control designs aim to reduce pressure on older underground infrastructure. These features are often grouped under terms like green infrastructure or sustainable urban drainage. The key idea is simple. Do not rely only on pipes. Also give water more chances to slow down, spread out, soak in, or be stored before it overwhelms the traditional drainage network. That matters because no storm drain system can make water vanish by magic. It can only redirect it, delay it, store it, and move it more safely. And when rainfall exceeds the design capacity of the system, flooding can still happen. That is why the best stormwater management is not just underground, it is layered. It includes inlets, pipes, culverts, channels, basins, landscaping, planning rules, maintenance, and emergency response. It also depends on ordinary people not dumping half a garden's worth of leaves and rubbish into a curb drain, and then acting surprised when the street becomes a shallow lake. So why do these systems matter more than most people realize? Because they quietly support nearly every part of urban life. They help protect roads, buildings, electrical systems, transport routes, public spaces, and homes. They reduce erosion and help manage runoff. They shape how land can be developed. They influence flood risk, water quality, and even public safety, and they do all of this mostly out of sight. That is what makes storm drain systems such a perfect example of hidden infrastructure. They are only obvious when they stop working, and perhaps that is the strange fate of the best infrastructure. If it does its job properly, most people barely notice it exists. The next time it rains in a city, watch where the water goes. Watch how the road is shaped to guide it. Watch how gutters channel it. Watch how it disappears into grates near the curb. And remember that beneath your feet, beyond what you can see, there is an engineered network trying to keep the city dry. Not glamorous perhaps, not usually celebrated, but absolutely essential. Because beneath every street after the rain begins, the city is performing a quiet act of hydraulic choreography. And the storm drains are the stage crew, making sure the whole production does not collapse. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.